This is the review for the non-calculator portion of regular pre-calc Unit 3 test. Ignore this. I didn't have a blank copy of your exact one, so we're going to make a few changes to this one. There are 10 multiple choice questions. That's it on the non-calculator part. Of course, all or without the calculator. You'll have to switch something from degrees to radians. Again, without the calculator, you're going to multiply by pi over 180. Now, probably the easiest way to do this, if you think about this 160 over 1, let's just get rid of the zeros. If you get rid of 1 0 each, it's like dividing by 10. Now you have 16 pi over 18, and that's much easier to reduce than with the zeros on it. 2 goes into each one of those, so 2 goes into 16, 2 goes into 18, so we end up with 8 pi over 9. Now your problem isn't this one, and your answers aren't like this, but we're going to go through this. This should say 240 degrees, and this should say that your radius is 3. Now the answers are very similar, except that instead of all the 5s, you have all 3s. This is not on the unit circle with the 3, but the 240 is. So I'm going to draw it. I think that's still the best way to do it. So if you think about where 240 degrees, you're right here in the third quadrant. You always draw your triangle to the x-axis. Well, 240 minus 180, since we're past that, 240 is bigger, we get 60. This is 60 degrees beyond the 180. Your hypotenuse is 3. Well, the side opposite the 30 is the short leg. You take the hypotenuse and divide it by 2. That's how you get the short leg. That is your x value. You are negative. So that is negative 3 over 2. If that's enough for you to stop and you're able to select an answer, it looks like our x value is not this or this, right? Because it's got to be negative 3 over 2, so it's either A or D. Now to get to the long leg, you would take the short leg, 3 over 2, and multiply by radical 3. This is down, so this one's negative, and so we get 3 radical 3 over 2, making that A. So you do have to know a little bit about the 30, 60, 90. The sine of 5 pi over 3, whatever's going to help you with that. If you need to draw it on the unit circle, if you need to draw the unit circle, there's lots of unit circle questions and inverses on there. So drawing it might, draw it once and use it many times. Might be worth your time. So you've got 5 pi over 3, which maybe you don't know that, but pi over 3, oops, that's pi over 6. Pi over 3 would be straight up, and so pi over 3 is 1/2 radical 3 over 2. So the sine is radical 3 over 2. But we're in the quadrant. All scholars take calculus. We're in this quadrant right here, so it's negative. For number 4, do each one separately. The cosine of 2 pi over 3. Well, this is 2 pi over 3 right here. So the cosine of that is going to be negative 1/2. The sine of pi over 6, that's this one. And so the sine is the y, or the y value, so you're up 1/2, so that's positive 1/2. When you add those two things together, you get 0. Now for this one, I'm looking at it because it's different. Your question says cotangent. So let's talk about the asymptotes for cotangent. You know the period is pi, and the first asymptote is on 0. The next asymptote is on pi. The next asymptote is on 2 pi. We could go backwards. That would be at negative pi. So you're looking at whole numbers. You don't have any fractions, so that gets rid of anything with a 2 in the bottom. And it says that n has to be an integer, so we have to make sure we understand that it could be 0, 1, 2, 3, and all those numbers. So if we're constantly multiplying by 2, it's probably not going to work every single time. We want to make sure we get them all. So that would make A the location for the asymptotes. For number 6, you can see the amplitude is 2. So amplitude is 2. It's either this one or this one. And then the period is 2 pi over b, which is pi over 2 once you reduce it. So that makes this b. Now for problem number 7, clearly cosine is your only choice. So you got to think cosine. Cosine starts high and ends high. So if we think about what that looks like on this picture, it starts here, ends here. It's a little bit hard to read on purpose, so that's not completely easy to do. Also, you can tell it's not been flipped over, so we can get rid of the ones that have a negative in them. So it cannot be A or C. So that leaves us with these other choices. Well, they both have a -1, and they both have an amplitude of 3. So if we count down 3, it does take us to a -1. So your midline is -1, and we're dealing with 3 cosine. So the only thing left is it 5 over 4, is it 4 over 5? Well, that comes from the period. So the space from these two high to high spots is 2.5. Well, you should really call that 5 pi over 2 to make it easier. And you know the formula is period equals 2 pi over b. Well, the period is 5 pi over 2. That equals 2 pi over b. I would cross multiply. So we would get 5 pi b is equal to 4 pi. You're solving for b, so divide by 5 pi. So you can see you get 4/5. So you need to have 4/5 and of course the x. That makes the answer D. The range of the inverse sine. Well, inverse sine, if you think about it, we know that the sine lives from here to here. This is negative pi over 2. This is positive pi over 2. So it's A. Now they're asking you what angle has a sine of negative radical 2 over 2. Well, we know that's pi over 4, but we're not allowed in these two quadrants. We're only allowed to use the definition of the inverse sine. The directions do not give us permission to use 0 to 2 pi, so you're on the restricted domain. So it's not positive here, or I mean it is positive in the first quadrant, so that means it's negative in the fourth quadrant, so we have to move down, so it's negative pi over 4. Or does the tangent equal radical 3 over 3? Well, I see 2 3's, so that means it's got a 6 in the bottom. It's pi over 6. It's positive, so it's in the first quadrant. Well, pi over 6 isn't a choice, but 30 degrees is the equivalent to pi over 6. Another question about the inverse functions. Inverse cosine. To define the inverse cosine, what restriction did we place on the actual cosine function? This was last week, and if you think about how the cosine curve looks, we talked about how it doesn't pass the horizontal line test. So we have to chop it up right in half. This will make it pass the horizontal line test. Well, the halfway spot on cosine, if the period is pi, halfway is, or the period is 2 pi rather, halfway is pi. So we have to restrict the domain to 0 to pi. You know that we have to use positive 1, and you know we have to use negative 1, and so then your choices really come down to A or C, and that's why it's C. And then finally for the last one, what is the value or what angle has a inverse cosine of negative radical 3 over 2? Well, again, cosine lives up here. Cosine's positive here and negative here, so we're in the second quadrant, so that gets rid of that. Now you have to know, is it pi over 3 or pi over 6? Well, it's up to you. How are you going to know your unit circle? It's pi over 3, but we're in this quadrant. So this is 3 pi over 3, and we're one less than that, so that's 2 pi. Oops, sorry, it's not pi over 3. You probably know that. It's pi over 6. My fault. So we know that it's pi over 6. And so we're in this quadrant, so this is 6 pi over 6, so one less is 5 pi over 6. So ignore the rest of those questions. You don't have those and you won't. So this is a few extra questions just for a little bit extra practice, but there are only 10 multiple choice questions on the non-calculator part.